So we've learned about the different numeral systems. We saw the decimal numbering system, which is the one we use, base 10. We saw the hexadecimal numbering system, which is base 16. And we also saw the binary numbering system, which is base 2, bicycle, biplane. I'll stop there. So with the binary numbering system, it's all zeros and ones. It's all zeros and ones. And if we wanted to represent the number 1 in binary, that would look like this. So the number 0 in binary is this. The number 1 in binary is that. The number 2 in binary is that. The number 3 in binary is that. The number 4 in binary is that. So remember, that's the decimal number, that's the binary numbering system, the binary numbering system. It's zeros and ones. So there's this concept of bit shifting, where we could take this bit, like we had that bit right there, and it was 2. We could take it and we could shift it over, and maybe we'd have actually 4 zeros and ones there, right? Or 4 zeros and then 4 zeros, either combination, so that'd be a byte. But we could take this bit and we could shift it from there, and we could put it right there. So that's called bit shifting. And so we're going to see how to use iota in an interesting way here. And I'm going to go to the Golang playground, and we're going to learn about bit shifting and see that in action, because it's just kind of interesting to know about. And if you look at the different operators, two of the operators that you have here are for shifting bits, right there, those two. And so the Golang playground, we come in here, and I'm going to create a variable. So var x is equal to, let's do 0, 1, we'll do 2, and then we'll print that out, and we'll use format printing. And so the first time we'll print it out as decimal, and then we'll do a tab and a tab, and then we'll print it out as binary, and we want to pass that in. And I guess it could just be right here. We'll use the short declaration operator. We don't need package scope, and best practice is to keep your scope as narrow as possible. So now we're going to pass in x there. And we can see that I forgot to do format printing, printf, not print line. And so now we have 2 and %b missing. I need another argument to pass into that. So we have %2, which is, we have %d, which gives us 2. That's decimal, the decimal numbering system. And we have 1, 0, which is the binary numbering system. This is the 1's place, 2 to the 0. This is 2 to the 1. This is the 2's place. If we had the number 4, right, that's going to be 1s, 2, 4. So this will be 4, and this will be 1, 0, 0. And so there's our decimal version. So now we can do bit shifting. And to show bit shifting, I'm going to copy this and then paste it down here. And I'm going to have this be y. And I'm going to say y is equal to x, but shift that over 1. So I'm going to format that. Y declared and not used. Y, I get so excited, I just run stuff. Y declared and not used. And I'm going to put a new line in at the end of this one here. The \n, new line, run it. And so now we went from here, which was, if this had a 0 in front of it, it would be 0, 1, 0, 0, to 1, 0, 0, 0. Right? So we shifted the bit over from this place, which was the third place over, right there, third place over. We shifted it over 1. And so that bit shifting is taking us from 4, right, the 1's place, the 2's place, the 4's place, and then it's taking us over to the 8's place. And that actually creates the number 8, because we shifted that over. We shifted it over. So that's bit shifting. And let me copy this code and put it into our course outline. So the next thing we want to look at is how can we use iota in a creative way? And I'm going to kind of build up to it. And we have one more step to get there. And so the next step to get there, and this is where we left off, is to take a look at, a kilobyte, a megabyte, and a gigabyte in binary. And so to do that, I'm going to get rid of this code. And so x will be a kilobyte, which is 1,024 bytes. Y will be, we'll do it just KB, kilobyte, right? And then megabyte will be kilobyte, which is 1,024, times another 1,024. And we're using the exact numbers here. I said earlier 1,000, but 1,024 is the exact number. And then a gigabyte is equal to 1,024, this makes more sense, megabytes. And so that's equal to 1024 kilobytes. All right, so a kilobyte is 1024 bytes. A megabyte is 1024 kilobytes. A gigabyte is 1024 megabytes. And now I'm going to print all that out. Format it and run it. So now you can see that here is 1024 bytes is a kilobyte, and then 1024 kilobytes is going to be a megabyte, so that's 1024 times 1024, and then a gigabyte is 1024 times 1024 times 1024. And each time this goes up by 10 zeros. So the decimal place, sorry, the binary digit shifted over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then here we have it shifted over 10 again. I'm going to take out one of these tabs just so we could see that a little bit more clearly. And here it shifted over 10 one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 right there, 6, 7, 8, 9, 10. Perfect. So each time it's shifting over 10. So this is a great candidate for using IOTA because we need something to shift over 10, 10 each time. So let's look at how we'd put that code together. But first I'm going to copy and put this into our course outline. Okay, cool. So now let's use IOTA to accomplish the same thing. And to do that, I'm going to come up to constant and put my parens and then bring all this up here. Whoops, bring all that up there. And take away the short declaration operator because that can only be used inside of a code block, inside of a function between curly braces. And so we have KB, and that should all still run. Nice. And now we want to use IOTA. And so the very first IOTA, if I just had another variable here, IOTA, and then print that out, that first IOTA is going to be 0. I'm going to throw that first IOTA away and not use it. And now I have 1024, or that's going to be the same as a kilobyte is this many. It's 1 shifted over 10 times. So this is what it used to be, just, hey, this is 1024, but I could also use bit shifting and say I have a 1 and shift it over 10 times, and this will give us the same result. So just look at the kilobyte bit right there. So that's the same result, but now how could I use IOTA and have that scale, right? So I want that to scale as it goes up. So I could do IOTA times 10. Right? So I'm going to take, this will shift over 10. That'll evaluate to 10. And then the next one will shift over 20. So I'll drop this one down here. And this one down here. Right? So this is going to shift it over 10. It'll take that 1. It'll take this 1 and shift it over 10. This one is going to be IOTA, which this will be the 0 IOTA. This will be the 1 IOTA, shift over 10. This will be the 2 IOTA. So it will shift over 20. And this will be the 3 IOTA, so that will shift over 30. So that's a pretty nifty little example of using IOTA. IOTA, code or do not code, there is no try. Do or do not, there is no try. So that's pretty fun. I like that. And if you look at what we're doing right here, that is some pretty awesome code. And it's a little bit too clever. It's a little bit too clever and a little bit too concise, but it's still sticking to idiomatic Go. And if you look in the language specification at IOTA, you know, using, doing bit shifting, you know, that's part of what is recommended in the language. So it's a little bit more complex. I say it's a little bit too clever because you want to go for readability. You want to write code that the average developer could look at and understand and not have to spend half their day going, the heck's going on here, right? But, you know, so bit shifting is a little bit esoteric, but now you're familiar with it. And I would say this is fair play if you wanted to use it in your Go programming. It's not too clever, but just be aware, you don't want to write code that's too concise and too clever at the expense of readability and, you know, just having other people be able to come in and understand your code base and work on it. So I just want to compliment you. I think you're doing an outstanding, amazing job. I think that we are together. You're learning some great skills. I've always valued and appreciated when I was a student and I worked with a teacher as like a team. It was a team effort, and we were doing something together in school, learning, being helped. And so I see this the same way. And we're doing a great job. And you're doing a great job for staying in here and continuing to do it. Because if you just stick with it, that's the key to success, persistence and grit. So I commend you and I congratulate you for continuing to hang in there and continuing to learn this stuff. Because if you look at this code right here, man, you're learning a whole other language. Parlez-vous français? Salamalat Tingal, Shia, whatever, all these different languages in the world. Now you're learning the Go language, and you're learning how to read it and how to speak it. And this is you're a good ways into the language here to be able to understand bit shifting and iota and constants and format printing. So good for you. We're doing great. And I congratulate you and commend you, and it's fun. It's really cool to be able to control these machines. And so I just wanted to say, yeah, keep it up. You're doing fantastic, and I'm enjoying it, and I hope you are too.